right, today's morning math with Matt.
Episode 3, the Triforce.
3 for the Triforce. Okay, so we have a horizontal line. How long is the horizontal line?
1 foot long. Exactly
Okay.
the same size as this ruler.
Okay, so
It's my sister's.
what are we going to make? What shape?
A triangle.
Okay, what kind of triangle?
Pascal's triangle.
Well, yes, ultimately it will be Pascal's triangle, but
An equilateral.
nice, equilateral triangle.
Equilateral acute.
Yes, all equilaterals are acute. How do we know that?
Has to be acute.
Yes, how do we know that they're going to be in a how do we know it's going to be an acute triangle?
Because for all the same sides, for all the sides have to be the same length, they have to all be the same angle.
Yes, they do.
And if they make either right angle, it would end up to a square.
Okay, so wait.
But if they one more. But if they use an obtuse angle,
Mhm.
then it'll end up to be a hexagon or pentagon.
Okay, so here's the difficult question.
Mhm.
First, let's make sure that that's 1 foot long, right? Because it has to be 1 foot.
It just came off when I was.
Yeah. How do we know what size the angle's going to be?
90, less than 90 degrees.
Okay, so when you're making a triangle, how many degrees are in that triangle?
I don't know.
Oh, okay.
I don't think we have learned that
You
yet.
didn't learn that yet? Okay, a triangle has 180 degrees. Okay, so maybe write that down here because we're going to do some division, just like you wanted to do today.
Yay.
Okay. We got to split up the 180 degrees so that it's in 3 equal parts for the 3 angles of a triangle.
Okay. So, 6.
6 degrees? 60 degrees.
60 degrees.
Okay, so every angle has to be 60 degrees. So I have this.
So
Right.
instead
We have
of
this.
an angle like this, a straight 90, we're going to be cutting it off a little bit,
Oh, but that word little bit. How much is a little bit?
30 degrees.
You're going to cut off 30 degrees? How do we measure degrees?
With a protractor.
Yeah, so I got the protractor. So I will do
I
the...
thought that's a compass.
It is. It's a protractor compass in one because that's how we roll. So we're going
Oh
to...
yeah, it is. There is a protractor.
Yeah, see? Okay, so we're going to put the eye there. We're going to measure it on the bottom. And you see that 60 degree mark?
Mhm.
Okay, so we're going to mark 60 degrees.
Wait. Okay, so 60 degrees.
Okay, there you go. All right,
I
so
marked
now your straight has to go from the corner here, but you have to do it so it's a 1 foot, just like the base angle, the base measurement is. So go ahead.
Okay, so let's take our 30 centimeters.
Make sure it touches. Nope, you got to make sure it touches so that it's straight and it's going to make...
Exactly 1 foot.
Okay, now the missing side should also be 1 foot. Not sure if that's going to happen there. Oh, I feel like we didn't make it correct.
Yeah, I think we went a little too short.
Yeah, all right, so let's erase this. Let's erase it.
Yeah, so we made too tiny of an angle.
Too tiny of an angle. Let's try this again. Okay.
Okay, so maybe we'll try
It's supposed to be 60,
the 65 mark.
but it's supposed to... It's supposed to be 60 degrees. I feel like my eye is not lining it up appropriately. All right, I'm going to show you a different trick. Hold that camera.
Okay.
This is something that we learn in geometry class. But it's only going to work if my face is only 10 inches. Can I have the ruler?
Yeah, so we'll make it 10 inches.
Okay, so we're going to change the base. Do, 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 do.
Okay, 1 second. Let me measure it to 10. Well, from 10.
All right, cool.
10 inches.
10 inches.
Okay.
Because it's on a whiteboard here. Okay.
Why does it only work for 10 inches?
No, it's not going to work because...
Is it because a donut used to be there?
Yeah, it's not going to work. Okay. Only because it's on the whiteboard and it's like falling down a little bit.
been going for 5 minutes.
All right, you can stop it.
No, I'm not going to.
You're not going to?
Yeah.
It's hard because it's on the whiteboard and it's like getting wet.
Okay, how about, wait. You hold.
There we go.
Straight line. There we go. We finally got an. And after this line, we're going to have an equilateral acute triangle. You can just say equilateral, actually.
You can just say equilateral because all the sides are the same.
Mhm.
They're all 12 inches, right?
Mhm.
Okay, so we're going to find half of 12 inches. What's half of 12 inches?
6 inches.
Okay, so we're going to mark off 6 inches. I'm going to do that with the green marker.
Okay. In a second, I'm going to put the camera not in it. Right. So we are finding the halfway point. 1 second, I gotta. 1 second. There we go.
Okay, I'm going to connect all those points together.
And this creates the central triangle of the Triforce.
Yes.
And once we do this triangle, it is all finished.
Well, it could be finished if we want it finished. But what did I do to get the green triangle from the blue one?
You had to make one big blue triangle, find the center points in each one, and then draw a triangle connecting them all.
Okay, so what if we do that with the green triangle? What if we find the midpoints of the green triangle? If the green triangles are measured are 6 inches, what's half of 6 inches?
3 inches.
Okay, give me the blue.
Wait, I'll mark it off.
All right, so go 3 inches. Okay, 3 inches. And then 3 inches. Okay, so
Can you hold it?
yeah, so again, and connect it again with a straight edge. What did you make now?
An even shorter triangle.
Mm-hmm.
And if you turn it upside down,
It's another what?
Triforce.
Another Triforce. Can you do the same method to this blue triangle?
Yes, you can do it infinite.
Whoa, nice! You can divide it up infinite number of times, right?
Mm-hmm.
Because then
Well,
you...
until you reach 0, because you can't divide 0.
Well, technically you would never reach 0.
Why?
Because you can still divide in half and then you never get 0. Because we have 3, right? The measurement here is
yeah.
blue is 3. Half of 3 is 1.5.
Oh, yeah.
And you can cut 1.5 and then but you'll never cut down and get 0. 0 is not half of something else, right?
Mm-hmm.
So when you make a pattern like this, that is the same image repeated itself over and over and over again, this is something that we call fractals. And the repetition of the same triangle, equilateral triangle inside of itself over and over again is really important. And you can do it here too. Like you could divide this section and, right?
Mm-hmm.
If I measured it out, and I can divide this section if I measured it out. And you can repeat that pattern over and over and over again. Now you want to hear some crazy, crazy, crazy stuff?
Yeah.
Okay, what is perimeter?
The sum of all of the lengths of the sides of a shape.
Very good. So the big triangle, right, was 12 plus 12 plus 12. What's the perimeter of the big triangle?
So 12 times 3
Mm-hmm.
equals 36.
So the perimeter is 36 inches, right?
And if
So if I wanted to put
if anybody in elementary school is watching this, it's going to be 12 times 3, like that.
yeah, but we don't write the X's in high school because it freaks people out. Okay,
Why does it
so
freak people out?
because it looks like 12x3. X means something else in high school. Okay, so here's the trippy part, and then we're going to stop.
The tricky part?
The trippy part, meaning it's going to make your mind hurt a little bit.
Trippy.
Trippy.
I never heard that.
All right, so the perimeter of the big object
Mm-hmm.
is 36, right?
Mm-hmm.
If you can make infinite number of lines, right? You can keep on cutting these up into smaller and smaller and smaller triangles. What's the perimeter of all the shapes?
All the shapes right now?
No.
Infinity.
There is, yes, the number of edges, right? The length of the number of edges within this triangle is infinite in nature. That's pretty cool stuff. So within a small finite space, you can have infinite number of edges. Does your brain hurt a little bit? You had to lay down for that one.
No, I just like to lay down.
Yeah, you're like, I gotta take a nap.
I was just upstairs enjoying the 1.16 update of Minecraft.
Oh, I understand. And then I made you do fractals. All right. Tomorrow we'll do Pascal's triangle and we'll get the same shape from Pascal's triangle. You want to do that?
Wait, isn't that Pascal's triangle?
No, Pascal's triangle is this is developed within Pascal's triangle. I'll do it tomorrow with you.